Hello, and welcome to day 2 of 11.7 notes. Yesterday we talked in the video about how to factor polynomials that were quadratic and trinomial, so degree 2 and has 3 terms, but the leading coefficient had to be prime. So this number out front with the highest exponent had to be 1 times something. Today we're going to talk about anything else. So the leading coefficient can be anything prime or not prime. So this pretty much opens up the rest of every trinomial factoring to us. The directions, though, are exactly the same. I'm still going to factor out the GCF first, so always do that first. It does make your life much easier. So I'm going to look here. Does anything go into 4, 4, and 15? Well, no, the factors of 15 are 3 and 5, so no GCF. I'm going to find factor pairs for A and for C. So now, because A is no longer prime, I am going to have a couple different options there. So to get 4, I could do 1 times 4 or 2 times 2. To get 15, I could do 1 times 15 or 3 times 5. So I do have a couple more combinations of things that I can actually try. So I'm going to go ahead and just pick one. I am going to go ahead and write this part in pen. I like to just pick one of these guys starting out. Doesn't really matter which one you pick. We're going to try all the options. I like to try the ones that are closer together and not the extreme ones first, just because that's generally more likely to be the answer. So I am going to go ahead and say 2x and 2x. So I'm going to go ahead and force those guys, and then we'll try 1 and 4 if we need to. All right, so I'm going to go ahead and use my pencil, and I'm just going to pick some of these options here. So let's go ahead and try, I'm pretty sure 3 and 5 is correct, so I want to go ahead and try 1 and 15 just to show you what we would do. So I would put 1 and 15 in there. And then I would do exactly what we did yesterday. I would check the inner product. 1 times 2x is 2x. And I would check the outer product. 2x times 15 is 30x. Does 2x and 30x give me negative 4? Well, in no form or fashion will that work. 30 minus 2 is 28, or 30 plus 2 is 32. So there's no way. So 1 and 15 do not work. Normally we would swap them and put a 15 and a 1, but because it's 2 and 2, it's the exact same thing. So I now know that 1 and 15 do not work with 2 and 2. So I'm going to try 3 and 5. So I'm going to put a 3 here and a 5 there. All right, inner product. 3 times 2x is 6x, and 2x times 5 is 10x. Well, can 6x and 10x give me a negative 4x? Well, 6 and 10 added give me 16, but 6 and 10 subtracted give me a 4. Then you just got to figure out your signs. Well, I want a negative 4x. So I want a negative 10x and a positive 6x. Okay, let's try that. In order to get a positive 6x, my inner product must be positive. So positive 3 times positive 2x gives me a positive 6x. My outer product needs to give me a negative 10x, so 2x times negative 5 gives me my negative 10x. And then always check your sign here at the end. Positive 3 and a negative 5 give me that negative 15. So I'm going to go ahead, I did work my way through, but my final answer is now going to be 2x. This plus 3 worked out, and 2x minus 5. So always check your answer at the end, though. 2x times 2x is 4x squared. 3 times negative 5 is a negative 15. And then I already checked my inner and outer product. I got a positive 6 and a negative 10, which gives me a negative 4 overall. So this is my final answer. Okay, for our second example, we're going to do the exact same thing. I'm always going to check for my GCF. So I like to look at my smallest number and see if it goes into any of them or if any of its factors go in. Well, 6 does not go into 10 or 19. The factors of 6 are 2 and 3. Well, 19 is prime, so nothing goes into it besides 19, but 2 and 3 don't go in everything. So there's no GCF. I'm going to find my factor pairs for A and for C, so I'm going to label what I possibly could get to multiply. So 10 is 1 and 10 and 2 and 5. 6 is 1 and 6 and 2 and 3. Again, just pick one of these leading coefficient terms and just stick with it. So I'm going to go ahead and I always pick the smaller of the two, 2x and a 5x. Okay, if I'm wrong, I'll have to try all these examples and then just try 1 and 10x. So If I'm wrong, it's a lot of work, but I can still make my way through. Okay, so I've chosen 2x and 5x, so now I'm going to go ahead and use my pencil and work my way through the examples. Again, I like to try the smaller numbers first, so I'm going to go ahead and put a 2 and a 3 here. I'm going to check my inner product. 2 times 5x is 10x, and 2x times 3 is a 6x. Well, 10x and 6x added together give me 16. Subtracted give me 4. They do not give me 19. So therefore, 2 and 3 do not work in their current order. But if I swap them, I do create a different problem. On the last one, we had a 2 and a 2, so swapping didn't make a difference. But here, swapping will make a difference. So I'm going to try 3 and then 2 before I say it's officially not working. Well, 3 times 5 is 15x. 2x times 2 is 4x. All right, does 15x and 4x give me 19x? It does. Those are pretty easy to see that they add together. So I need a positive 15 and a positive 4. Well, my inner product needs to be positive, and my outer product needs to also be positive. Okay, let's go ahead and make sure our last products work. Does 3 times 2 give me a positive 6? Yes. Does 2x times 5x give me a 10x squared? Yes. So it took me 2 tries and then I got it. So I'm going to go ahead and copy this answer down. My answer is 2x plus 3 and 5x plus 2. So these, if you choose correctly starting off, it's not a lot of work. If I had chosen to do 1 and 6, I would have had to do 1 and 6. It would not have worked. I would have swapped places and done a 1 or a 6 and a 1. It would not have worked. If you'd start with 1 and 10, you obviously would have had to go through all these combinations and none of them would have worked. So it does help to get lucky sometimes. Just choose the right thing right off the bat. But as you do these more often, you'll get better at spotting ones that definitely don't work. All right, moving on to example 3. Step 1 is factor out the GCF. So does anything go into 9, 24, and 12? Well, yes, 3 goes into all of those. This is 3 times 3, 3 times 8, and 3 times 4. So 3 is my greatest common factor. Please do not skip this step. Actually go ahead and write out 3 parentheses and then divide each term by 3 so that you know what's left over. People try to skip, and they'll know that 3 comes out, but they'll try to just skip this step and factor in their head, and it's really difficult to do that. So I'm going to go ahead and actually figure out what comes down. So that's going to be 3x squared, negative 24 divided by 3 is a negative 8x, and 12 divided by 3 is a positive 4. So now that I have that, then I'm going to go ahead and look at my factor pairs. Well, 3 is 1 times 3, and 4 is 1 times 4, and 2 times 2. Which actually, by finding the GCF, we created kind of like yesterday's homework, where we only have one combination here, so it's really not that bad. So I'm going to go ahead and bring my 3 straight down, and I have to have a 1x and a 3x, because those are my only options starting out. So I'm going to go ahead and write that in pen. And then I've got to work my way through 1 and 4 or 2 and 2. So I usually like to start with the 2 and 2. So I'm going to go ahead and try those guys out. Check your inner product. 2 times 3x is a 6x. 1 times 2x is 2x. Oh, we got lucky on the first try here. 6x and 2x can give me a negative 8 if I make them both negative. I want to have a negative 6 and a negative 2. They are going to add to be negative. Well, my inner product must be negative, and my outer product must be negative. Always check your sign. Does negative 2 times negative 2 give me a positive 4? Yes, that guy's fine. Let's go ahead and just check the rest while we're at it. Does 1x times 3x give me 3x squared? Yes. And double check again. This is in fact negative 6 and a negative 2. Negative 6 and negative 2 added together give me a negative 8. So we actually got the answer right off the bat. So this guy, don't forget your 3 out here. I'm just going to go ahead and instead of writing 1x, I'm going to write just x. So it's 3 times x minus 2 times 3x minus 2. So that's that final answer on that one. Okay, well, going over and looking at this next example, if you feel like you got it, go ahead and pause the video and try it on your own. Otherwise, just hang out and we'll go through it. All right, so I'm going to go ahead and always factor out the GCF. So let's look through. We got 8, 14, and 6. Well, they're all even, so I know at least a 2 comes out, maybe a 4. Oh, but 4 doesn't go in there or there, so it must be a 2. So I'm going to go ahead and take out a 2. But this one's a little different. We said earlier we can only factor degree 2 polynomials. Well, actually, in this case, trinomials. This is a degree 3, which should be a hint that something else must come out. If we look at all 3 terms here, they all share an x. So the GCF is actually 2x. We've not done any like this so far. So I'm going to take out a 2x. I like to divide my terms by 2x, 2x. So, and actually go ahead, do not skip this step. You have to know what's inside here in order to do the rest of the factoring. So 8 divided by 2 is a 4. 3x's take away 1 is x squared. Minus 14 divided by 2 is 7. 2x's take away 1 is just 1x. 6 divided by 2 is a positive 3, and the x's cancel. So now I have this. So not too bad. 8 would have been terrible to try to factor. I would have had 1 and 8, 2 and 4, 2 and 3, 1 and 6, and I would have had all kinds of stuff. This definitely cleaned up a little bit. This 3 is just 1 times 3, so I did create myself an easier problem. So I'm going to go ahead and write the factors of my a value, which is 1 and 4 and 2 and 2, and my c value, so 1 and 3. All right, I like to go ahead and do the even one or the closer together one, so I'm going to go ahead and say 2x. That's why I'm just bringing this guy straight down. I'm going to put a 2x and a 2x. This one, it might have made more sense to maybe force the 1 and 3 at the end, but we're in the habit of doing the beginning parts first, so we'll just stick with it. All right? Well, these are actually the same thing twice. So a 1 or a 3 and a 3 or a 1 won't make a difference. So if I try it once, it doesn't work, then we clearly chose the wrong initial pairs. Inner product, 1 times 2x is 2x. Outer product is 6x. Well, can 2x and 6x give me 7x? No. Which there's only one way to do the 1 and the 3. It doesn't matter if I swap them. So the thing that's wrong is actually this 2 and 2. So that's wrong. It must be 1 and 4. So now I'm going to have to do it again. I'm going to go ahead and just do it in blue pen here. So I'm just going to try again. So I'm going to put a 1x and a 4x. I only have one possibility. It's a 1 and a 3, but it does matter the order. So just pick one and go with it. So I'm going to go 1 and 3. I'm going to check my inner product, which is 4x. And I'm going to check my outer product, which is 3x. Does 4, it's a little hard to read, does 4x and 3x give me 7x? Yes, if I make them both negative. So my inner product is negative and my outer product is negative. Okay, let's make sure. Does negative 1 times negative 3 give me positive 3? Yes. Does 1x times 4x give me 4x squared? Yes. Double check. Negative 4 and negative 3 is negative 7. So this middle guy was completely wrong. So if you did it all in pencil, you don't have that. But once I figured out it wasn't 2 and 2, once I figured out it was 1x and 4x, I just had to move those around, and I just got lucky the first guess. So I'm just going to go ahead and fill in these guys in pen, since I ran out of space. And this is my final answer. Please do not forget that GCF of 2x.